Hello everyone, welcome to lecture 1.1 of testing of hypothesis. In this lecture, we are going to do a problem under the topic test for the significant difference between sample mean and population mean. First, we'll see the procedure. Step 1, write the given data. Step 2, write H0, H1. Step 3, find the test statistic Z. Step 4, write the table value. Step 5, write the inference. So, in testing of hypothesis topic, in large sample, we are going to do one problem. A sample of 400 students have a mean height 171.38 centimeters. Can it be reasonably regarded as a sample from a large population with mean height 171.17 centimeters and a standard deviation 3.30 centimeters? So here it is given. We have a sample size 400. So it should be large sample. So n is equal to 400, which is greater than 30. Therefore, we are in large sample. That is this problem coming under large sample. Next, the mean height is given. Mean height of the sample, that is x bar 171.38. X bar is given, and then population mean is given, that is mu is given, and then the standard deviation of the population is also given. So what are the data we have? Sample size, sample mean, population mean, and population standard deviation. So since n is greater than 30, it is coming under large sample, and then we are going to analyze if there is a significant difference between the sample mean and the population mean. So this problem coming under the topic test for the significant difference between sample mean and population mean. So first step, we are going to write the values of the given data. N is equal to 400, and what it is? It is sample mean. X bar is equal to 171.38 centimeter, and this is population mean. So mu is equal to 171.17 centimeter, and standard deviation of the population is sigma, which is given 3.3. So after writing the given data, we are going to write the H0. What it is? Actually, it is a null hypothesis. That is, there is no significant difference. It means H0 is no, nothing. There is no difference. So it should be always equal to. H0 should be always equal to. Something should be equal to something. This value must be the population parameter. So here we are going to check the difference between mean. So the population parameter is here mu. So mu is equal to 171.17. So the meaning, if H0 is true, then we can conclude that this sample come from the population with mean 171.17. So mu is equal to this. Then we have to write H1. This is called alternative hypothesis. This H1 may be less than, greater than, or not equal to. If it is less than, then we say it is left-tailed test. Left-tailed test. One-tailed test, which is left-tailed test. If we have greater than, then we can say right-tailed test. And if it is not equal to, then it is called two-tailed test. So if we are going to write not equal to here, then it is two-tailed test. If we have a less than, left-tailed test, greater than, right-tailed test. So here the question is, if this sample come from this population or not is the only question. So if it is come from this population, then we'll have mu is equal to this. If it is not, then mu must be not equal to. So H1 should be mu is not equal to 171.17. So it is two-tailed test. Next, we are going to write the statistic. The test statistic Z is equal to, here we have x bar, mu, sigma and n. So the formula is x bar minus mu by sigma by root n, which is equal to x bar 171.38 minus 171.17 is mu divided by sigma 3.30 by root n is root 400. So now we'll calculate how much it is. Usually students are making mistake while calculating the values. So what we are going to find, this value, Z value 171, put the bracket before this, bracket for numerator 171.38 minus 171.17, close the bracket for the numerator, divided by, put the bracket for the denominator, 3.3 divided by root of 400. Close the bracket now. If you put equal to, we are getting the answer 14 by 11 in fraction. So decimal, it is 1.272727, etc. So the value of Z is 1.27. This is our calculated value. The next step, fourth step, is to write the table value. Here we have two-tailed test and the level of significance is not mentioned. So we'll take 5% level of significant. So the table value of Z at 5% level, 5% level is 1.96. So what is the inference? Conclusion, mod Z, which is our value of modulus of 1.27, which is equal to 1.27, which is less than 1.96. So the calculated value is less than the table value. Therefore, H0 is accepted. At 5% level of significance. Therefore, the inference is, the given sample can be regarded as a sample from the population with mean 171.17 centimeters. So H0 is accepted. Our H0 is mu is equal to 171.17. That is, this sample come from the population with mean 171.17 is the inference. Thank you.